Lesson 2, Science. What causes physical weathering? I'm on page 236 in your science book. Natural forces on Earth also cause physical weathering. These forces slowly change the surface of Earth. Physical weathering. Remember from lesson 1 that I said you had to be able to compare chemical weathering to physical weathering. They are different. You read in lesson 1 that chemical weathering causes rocks to change into different materials and break down. Chemical causes a new material. Chemical weathering causes a new material. In physical weathering, rocks are broken into smaller pieces, but only the size of the rocks change. The rocks do not change into new materials. Plants, ice, and water all cause physical weathering. When they work together, rock weathers even faster. So chemical weathering, you have a mixture of substances and items in nature that mix together and they weather the rock by breaking it down but changing it into something new. Physical weathering is just breaking it apart. That's it. Have you ever seen a weed growing in a crack in the sidewalk? Weeds and other plants can also grow in cracks and rocks. As the plants and their roots grow, they split the soil and rocks. Roots break apart some rocks, such as granite, more slowly than other rocks, such as sandstone. So you have this root that maybe a seed somehow got stuck in a little crack in a rock, and as it grows, it's kind of, it's pushing, it's forcing its way out. Glaciers can also cause physical weathering. Glaciers are huge moving sheets of ice that creep very slowly over land. As the glacier slides along, it drags rocks with it. The rocks scrape along the ground, forming valleys and ridges. The glacier also grinds rocks into smaller pieces. We read about this in our, I believe it was in our performance assessment in our writing task. Okay, freezing and thawing. Ice breaks rocks as well. When water freezes, it expands or gets larger. Water from rain or melted snow seeps into cracks and rocks. As the water freezes, the ice pushes against the sides of the crack. This makes the crack deeper and wider. Each time this happens, the crack gets a little bit larger, and in time, the rock will split. So water creeps in the crack. That doesn't do anything. Water alone, just sitting there, isn't going to do anything like that. And it's going to happen very slowly. But when it freezes, it gets bigger. If you've ever, just like they're showing the sample on page 237, if you've ever put a water bottle in your refrigerator, your freezer, and then forgot about it, you came back and it's all swollen. If you ever made the mistake of putting a soda can in there, don't do that. And leaving that overnight in the freezer, you'll also see that it expands. And eventually, it's going to expand so much that it's going to pop out of the case that it's in, which is what happens in rocks. The ice just breaks out of the space that it was in. Think of a soft plastic bottle that's completely filled with water. The bottle is tightly capped and placed in the freezer overnight. What do you predict will happen? The water expands and changes the shape of the bottle. Sometimes the bottle even splits. How does this show that freezing can cause physical weathering? I just talked about that. 238, water and weathering. Look at the picture on the left. What do you think carved the hole through the rock? It was the water. The constant action of flowing water in waves shapes landforms along coasts. Sand and gravel in the waves act like sandpaper. As the waves crash against the rocks, the sand and gravel wear away the rocks. Then the broken pieces of rock, the sand, and the gravel all scrape against the rock the waves hit. The weathering process continues. So the water's hitting it, it chips it away, and now when the water comes down, it kind of drags some of those pieces with it, and now it's coming back with more force and more material, so it's going to break away even more, and it just keeps happening over and over and over. Flowing water shapes landforms too. Rivers carry pebbles, sand, mud, and other sediments. These sediments rub against the rock that makes up the riverbed. They slowly wear away the rock, leaving valleys and canyons. The picture below shows how flowing water carves a path through the land. You can see on page 238, it looks like a line that someone has just kind of went along and just scraped around there. But that's water going through there. That's water creating its path. 239, soil. As you have seen, the rocks at and beneath Earth's surface are affected by plants, ice, and water. Weathering breaks these rocks into tiny pieces. The little pieces of rock are ingredients in soil. Soil is the thin layer of loose weathered material that covers most of the land surface of Earth. The pictures on the right show how scientists classified the pieces of rock that make up soil. Most soil is made up of sand, silt, and clay. Soil also includes decaying plant animal matter called humus. Or maybe it's humus. Maybe it's humus. The exact combination is different for every kind of soil. Water and air fill in the spaces between particles of sand, silt, clay, and humus. The amount of each ingredient in the mixture determines what kinds of plants grow well in the soil. So on the sidebar, which is the text feature on the right, it says sizes of rocks, and they kind of give you a chart here that shows you a boulder, 300 millimeters. Of course, we never use metric system, but a boulder are the giant rocks that some of us have by our pools, the kind that a human cannot lift on his or her own. Then you go down to cobble, which might be like kind of the old-fashioned roads. They're called cobblestone, and they're about yay big. The rocks are about so big. So we can pick them up maybe with 2 hands, and then you place them, and they kind of made a road out of it. It's cobblestone. And then you go down into pebbles, which might be what we put at the bottom of our aquariums, or we use them for decor, just to decorate things in the bottom of vases. Then you have sand. Hopefully you know what that looks like. Silt is similar to black sand. It's even more fine. It's even smaller pieces than sand, if you can imagine. And clay, you might think of modeling clay, but we're talking about the clay you find in the ground. And when you dig, it kind of like, it feels waxy. It kind of feels like you can mold it a little bit. And if you can imagine, try growing a plant in a piece of clay. I don't think it's going to work very well because you don't have the roots that can do what they want to do. They're going to struggle to get through. But sand, on the other hand, has so many fine points. You stick a root in sand, what's going to happen? It's just going to fall down. Sand isn't strong enough to hold it up. So you need a good kind of soil that has a combination of everything to hold the root while it's doing its business, right? All right. More weathering, page 240. Over time, some rock breaks into tiny pieces as it weathers. But what happens to the larger pieces? The larger weathered pieces are the fantastic shapes you see in the photos in this lesson. Huge arches, like Arches National Park. Lost my spot. Towers and other shapes can be formed in this way. Notice how some of the weathered rocks look very smooth. Others seem to have sharp corners. You can also see some smaller pieces of weathered rock. Some of the weathered rock may have been moved by the wind or other forces. First, blowing winds pick up tiny bits of sand, soil, or dust. When the particles blow against a rock, they scrape against it. Next, tiny bits of rock break off. Then these bits are blown away. Pieces of rock and soil in open areas such as farm fields keep weathering. The top layer of soil, called topsoil, is the best kind of soil for growing crops. The roots don't grow very deep in those crops, so you need just that top layer to hold in the plant in place. Waves. You can see large pieces of weathered rock near the ocean too. Waves and flowing water break large rocks near the coast into smaller pieces of rock. The water and the wind carry away particles of rock, soil, and sand. The particles bump and scrape against each other and against other rock. Over time, they become smaller and smaller. Later, the water or the wind may deposit or set down these tiny pieces in other places. You will read more about this process in Lesson 3. We've heard the word deposit. We think of it in money. We put a deposit in the bank, which means we put our money in the bank. If you're going to deposit anything, you're just going to set it down. You're going to put it in its place. All right, that was Lesson 2. And with that, you need to complete your study guide packet, page 99.